Hello students, in the last lecture of embedded system course I discussed about microcontroller and how it is different from microprocessor. So you might be wondering why we going to study microcontroller in this embedded system course. So in this lecture I'll tell you the need of study of this microcontroller part in the embedded system course. So before going into the detail, let me tell you what is an embedded system. So embedded system, basically it is a application specific system, or you can say it is a dedicated system which contains both hardware and software that is tailored in such a way to perform a particular task, and these embedded systems are a part of larger systems. So what these embedded systems, they are a part of larger systems. They have both hardware and software part, and they are manufactured in such a way that they will perform a particular task only. That is, they are dedicated to a particular application. So the this embedded system cannot be used to perform another application, because the embedded system has been designed or manufactured or tailored in such a way that it will perform one particular application only. So what are the characteristics of this embedded system? They are dedicated systems. They are dedicated to a particular application. They include processors dedicated to specific functions. They contain real-time constraints, and they represent a subset of reactive systems. So these are the essential components of embedded systems. They contain microcontroller or DSP core. They have sensors, converters, actuators, memory, communication path with interfacing environment. So this embedded product uses microcontroller to do one particular task only. For example, here I have given the applications of embedded system. These are the embedded system applications. For example, printer. For example, printer is an example of embedded system, since the processor inside it performs only one task, and that is getting the data and printing it. Contrast to this printer or this embedded system is a Pentium based PC. This PC can be used for any number of applications. As I've told you that embedded system, or for example the printer, is used for only one application. Contrast to this is a PC which can be used for any number of applications, such as word processor, bank teller terminal, video game player, network server, print server, or internet terminal. So the software for a variety of applications can be loaded and run. Of course, the reason a PC can perform a myriad tasks is that it has RAM memory and an operating system that loads the application software into RAM and lets the CPU run it. Whereas in an embedded system, there is only one application software that is typically burned into the ROM. So this Pentium based PC contains or is connected to various embedded products. You can say this, as I've told you, this Pentium based PC can perform any number of applications. So this PC is connected to various embedded products, such as keyboard, printer, modern disk controller, sound card, CD-ROM, driver. As you can see, all these are the peripherals. So the Pentium based PC can be connected to any of the embedded systems. So as you can see, this printer is an embedded system, scanner is an embedded system, keyboard is an embedded system. So this PC can be connected to any number of embedded systems. So each one of these peripherals, as you can see, each one of these computer peripherals has a microcontroller inside it that performs only one task. For example, inside every mouse, there is a microcontroller that performs the task of finding the mouse position and sending it to the PC. So what I am trying to tell you, for example, what I am trying to tell you that as you can see, computer peripherals, you can see the printer. So here printer is an embedded system, or these are the embedded systems. Inside each embedded system there is a microcontroller which is actually performing that particular application. performing that particular operation. Then moving on, these are the other embedded system applications. These are all the embedded systems. These are the field where the embedded systems are applied. Like in medical field, we have embedded systems as like one-touch glucose meter. Then at most all medical facilities having the embedded systems. So a good designer should always know what type of controller he or she is using, their architecture, advantages, disadvantages, ways to reduce production cost and production reliability. So this is why we going to study about the microcontroller, because embedded systems are made up of this microcontroller. The essential component of embedded system is a microcontroller. Moving on to the evaluation of microcontrollers. So in the year 1976, Intel introduced the 8048 series of single chip microcontrollers. It is also known as MCS48. MCS48. It contains 8-bit CPU. The microcontrollers of this series are 8048, 8748, 8041, 8042, etc. These microcontrollers were popular and widely used for automatic control applications. These microcontrollers do not have multiplication and division instructions. Then in the year 1980, Intel introduced a more powerful 8051 series of 8-bit microcontrollers. So this 8051 series of the 8051 series of microcontrollers were developed in the year 1980. They are the second generation of 8-bit microcontrollers. They are faster and more powerful than this Intel 8048 series that I've told you, the first microcontrollers, that is 8048 series. This 8051 series of microcontrollers have been provided with improved instruction set and contain a number of additional electronic circuitry for specific functions. The 8-bit microcontrollers are used for a variety of applications involving limited calculations and relatively simple control strategies. They are used for industrial and commercial control applications, appliances control, instrumentation, etc. So this was all about the evolution of microcontrollers. I am ending this class here. In the next lecture, I will be discussing about the different types of microcontrollers, that is the categories of microcontrollers. I am ending this class here. Thank you.